Alright everyone, so in this video we're going to talk about molar mass. So we've talked already about how the mole is a unit of measurement and how we know that in 1 mole there's always 6.02 times 10 to the 23 of whatever it is. So if I had 1 mole of basketballs, that would be 6.02 times 10 to the 23 basketballs, right? Well, one thing that hopefully will make sense to you is that if I have, let's talk about a dozen. If I have a dozen cookies and I have a dozen socks, okay? In both of those cases, I have 12 cookies or I have 12 socks, right? These are the same numbers, but we know that the weight of 12 cookies is going to be different than the weight of 12 socks. These are not going to be the same number because they're not the same type of item. And so the same can be said for chemicals. Molar mass is what we use to measure the mass of the number of moles of an element or molecule. And the molar mass refers to the total mass in grams of an element, okay? And it can be written as an equality. So if we have 1 mole of carbon dioxide is always equal to 44.01 grams of carbon dioxide, or 44.01 grams over 1 mole of carbon dioxide. So it can be written as either an equality or as a ratio or fraction. And the unit for molar mass is always grams per mole or grams/mole. And what that's saying, like with this ratio here, is that you have 44.01 grams of carbon dioxide per 1 mole of carbon dioxide. But remember, chemists are kind of lazy. This one we don't really write, and the fact that it's carbon dioxide twice, we don't, we get a little lazy, so we just put 44.01 G/mol, or grams per mole carbon dioxide. We're kind of simplifying it a little bit. And the molar mass is easily identified on most periodic tables where it's listed for each element. The mass of 1 mole of each element is equal to the average atomic mass. So this is a really important thing. So the mass of 1 mole is equal to its average atomic mass, which is so convenient. So for example, if you look on your periodic table, the molar mass of carbon is 12.01 grams per mole. That's its average atomic mass. Oxygen, 16.00 grams per mole, and gold is 196.97. So remember, that is on your periodic table, your average atomic mass is the number at the bottom. And so to determine the molar mass of a compound, which has more than 1 element, you have to add up the molar masses of all the atoms present in the chemical formula. And you have to look to include how many atoms from each element you have. So you have to be careful of your subscripts. So for example, if we're looking at carbon dioxide, how did I know it was 44.01? CO2 is not on the periodic table. But because I have 2 capital letters, capital C and a capital O, that means I'm talking about carbon and oxygen individually. And we know that since there's no number after the carbon, that means there's just 1. Okay, it's an invisible 1. So when we talk about what molar mass means, okay, you should be able to get your answer for 1 and 2 from your paragraph. But when we look at number 3, where did the numbers 12.01 and 16.00 come from? These numbers come from here. So they come from the periodic table. They come from our periodic table. And the numbers 1 and 2 come from our subscripts. And so this is the example and practice page for my honors class. If you're in my regular class, then you should note that instead of giving the chemical names, I went ahead and gave you the chemical formula. But for example, for sodium phosphide, that has a chemical formula of Na3P. So that means what we do is we list out our elements. So I have sodium and phosphorus. We count how many we have. We're going to have 3 sodiums and 1 phosphorus atom. and we're going to multiply them by their molar masses from the periodic table. Now, sodium has a molar mass of 22.99, and phosphorus has a molar mass of 30.97. So we're going to need to multiply these values in order to get our answer. So 3 times 22.99 is going to give us 68.92. And 1 times 30.97 is 30.97. And because this is not two individual elements, this is one compound that we're trying to figure out the mass, we will combine them by adding them together. And when we add these two values together, we should get 99.94. Our unit is grams per mole, and we put our chemical formula with it. So our answer always has to have a number, a unit, and a chemical. So 99.94 grams per mole of Na3P. And for molar masses, whether you're in my honors class or in my regular class, you should always have two numbers after the decimal, because 3 and 1 are counting numbers. We have two decimals from our periodic table, so our answer should have two decimals. Now, what if your chemical formula looks a little bit different? For example, ammonium sulfate is NH4 in parentheses with a 2 and then SO4. Okay, so here's what you need to keep in mind is when we're doing this, okay, we're going to split it up by capital letters. So we have N, we have H, we have S, and we have O. Now, inside the parentheses, I have 1 nitrogen and 4 hydrogens. However, this 2 outside of the parentheses gets distributed to both the nitrogen and hydrogen because it's saying that I have 2 ammonium ions. So this means that instead of just having 1 nitrogen, in total I have 2. And I have 2 times 4 is 8 hydrogens, 1 sulfur, and 4 oxygens. And so we're going to need to multiply them by their masses from the periodic table. The mass of nitrogen is 14.01, hydrogen is 1.01, sulfur is 32.07, and oxygen is 16.00. So we take the time to multiply them out. 2 times 14.01 is 28.02. 8 times 1.01 is 8.08. 1 times 32.07 is 32.07, and 4 times 16 is 48. And then we add them all together. And I'm going to do that in my calculator just to make sure I don't make a mistake, which has been known to happen from time to time. And you should get 116.17 grams per mole of ammonium sulfate, so NH4 2SO4. And that is our final answer. And so this molar mass can be used in conversions, but for now, you will use this to practice calculating the molar mass of these remaining elements.